So once we do that, it's going to draw a grid. And you'll see that up on the top there is a time code in seconds. So this is the 0th second, the 1st second, second, all the way down to 1 minute and 2 seconds. And it adds, but just put a buffer on the end of it. Even though you typed in 1 minute, we throw a buffer on the end just to shut everything down at the end. And especially if you're doing a playlist, this provides a couple extra seconds between songs as well. So, and then each one of these seconds is chunked up into 20 different marks, which is that every 50 milliseconds that I was talking about. So you can actually go in here and start toggling, you know, things on in the grid just by using the keyboard, which is really annoying because you're not hearing music or anything. So you probably wouldn't want to do it that way. So turning this back off. The easier way to do it here is to, if you press the record button, it'll start playing the music, and you can tap out the sequence using the keyboard. So it'll map basically every row in the keyboard is 10 channels. So 1 through 0 is channel, the first 10 channels of fidgets, A through, or Q through P, you know, whatever 10 keys are, and that is the next 20, the next 10. I've never seen anyone go beyond 12 before, but I think I still have it. So actually I do have an answer for it. I think it supports up to 40 currently, because I only have 40 keys mapped. So every time you can go through this, you can do this at kind of a chunk at a time. So, and also you don't have the coordination to map 8 or 12 channels simultaneously and tap off the rhythm. So you can do it channel by channel or 2 or 3 channels at a time, and then you come back into the record and you do append channel data instead of overwrite, which will take whatever's in the grid and just add the data onto it. And you can also play the existing channel data. So if you have the lights already hooked up, you can watch them flash while you're recording the next set of lights, so you can kind of get a visual feedback of what you're doing at the same time. So let's quickly just do a quick thing here. And you'll hear the relays click as it's actually toggling the relays on and off as I'm doing this. So I'll just type some random junk here. I'll ask you if you want to save it or not, because if you screwed up, you don't want to save it back to the original grid. So we'll say yes, we do. And you'll see that all of my key presses have now showed up here in time that I typed them all out. Now when we go to play this back, and I don't have any lights hooked up right now, but you'll hear the relays click in the same way that I was typing them out. So there's really no special magic here, like it's not doing beat detection and it's not doing anything else. It's just recording when you're pressing the keyboard in time, saving those times, and then replaying them back. That's the only thing that's happening here. I don't think there's really anything else to show about this. So let me go back to the source code here so you can, hopefully it'll make a little bit more sense now. So in order to draw this grid, I wanted to have 2 headers. A header that had the full time, whatever second you're on, as well as the 20 markers in between. I used the standard data grid from .NET, from WinForms, data grid views. I don't know which one. It's the ASP.NET one and the other one, so it's the other. I don't remember which name is which, but it's that one. But it doesn't support drawing multiple headers. So this is actually 2 grids, one of which is just the height of the header and the other which is the full height. And using some event magic of on the scroll event here, we're grabbing the scrolling offset from the current grid, from the bottom grid, and then just applying that to the top grid, so they'll both stay in unison as you scroll the screen left or right. So it's a cheap and easy way to do a double header grid. So when we create the sequence, actually draw out the grid. It's a matter of just taking the music length, and for every second that's in that length, draw the headers. And then we have another loop inside, which is the number of sub-seconds, which in this case it's 50, so every 50 seconds you're going to do 20 parts per second. And then in that second grid, just creating the appropriate number of columns that would fit to fit the size. And you'll notice here I have, in a couple of places, they do a switch on sequence version. I'll talk about this in a second, but my first version of this, I used a Windows timer to do the timing, which I know was stupid, but I decided to do it anyway because I wanted to get it done. Windows timers really suck for timing. If you need accurate timing, you do not want a Windows timer because you will not get accurate timing. It's going to, you set it to 50 milliseconds and it will throw a event at you between 50 and 70 milliseconds. So with this, when you really need to, have an accurate count and accurate playback, it works for the most part, but it starts to drift. So after about a minute or two, you'll start to see things get more and more out of sequence, and after several minutes, it's way off in the weeds. So the second version, I still support the old version in case for people that crave their old sequences, but version 2 uses the system.diagnostics.stopwatch, which actually uses the hardware timer internally. It's the same as query performance counter if you've done Win32 stuff. So that's really, really accurate to within, a couple of milliseconds. So that's just an off-topic tangent. If you ever need to time things accurately, Windows timer is not your friend. So let's look at the record form, because that's where most of the stuff happens here.
What time did you use?
I'm sorry?
What was the timer you used again?
The system.diagnostics.stopwatch. Which you'll actually see in here. So the record form, this is where I map keys. So it's every 10 keys per row maps to a channel somewhere. So I've got 40 channels, as I just said. When you start recording, what I do is, well, depending on which version you're running, so it'll start a thread. In the newer time, the old time mode, it'd start a Windows timer. In the new form, it starts a record thread, which, basically sits in a very tight loop, which is, while the song is still going, check to see if we've passed 50 milliseconds, because that's, our parts per second. And if we have, increment a counter, which is we're going to have basically a giant array of every millisecond, or every 50 milliseconds. And that array is just a Boolean of on or off. So is this channel on or off at this specific time? So it sits in the loop, waits for that time to pass. If it does, increments it to the next position in the array, reads the keyboard to see if any of the buttons are pressed. If any of them are, it shoves them inside the array, in this temp data array. And we also will turn on the fidget output port right here, output channel of the output index, and whether or not we're on or off. So that's why you get the playback as you see it. And then we increment our tick count and grab the current time. So in our next loop back through, if we haven't elapsed enough time, it just sits and spins until we do have enough time. So it's a very tight loop. It'll chew up your CPU resources like crazy. You could probably throw in a thread.sleep in there if you wanted to in order to not have that happen, but for the minute that you're going to sit there typing stuff out, I'd rather not sit in not have a thread.sleep and worry about missing the next millisecond kick. So